Nakikita na po ba yung screen? Ayan.
Yes po.
Ayan, pwede na po kami mag-start.
Hello, rinig po ba?
Rinig po.
Alright, so good evening everyone. We are the group number 3 and we will be discussing about the electric locomotive. So before, we already discussed different types of locomotives and one of that is the electric locomotive. So tonight we will be discussing it in details. So next slide please. So the contents of our report are the characteristics of electric locomotive, the introduction of an alternating current, electric locomotive type, battery locomotive, power transmission, driving the wheels, and wheel arrangement. So basically, we will be focusing on the working function of an electric locomotive. Next. So first, let us define what is electric locomotive. So an electric locomotive is a locomotive powered by electricity from overhead lines, a third rail, or an onboard energy storage device. So basically, from the name itself, the electric locomotive uses electricity. So this electricity is supplied through overhead cables which carried alternating current or also known as AC. So these cables are connected to power stations that produce or that require that produce electricity, the required electricity to move a train or to run a train. Electric generator or motor functions as a power transmission system. Locomotives with onboard fueled prime movers such as diesel engines or gas turbines are classified as diesel electric or gas turbine electric locomotive. And lastly, electricity is used to eliminate smoke and take advantage of the high efficiency of electric motors. So since the main power of electric locomotives is coming from the electricity, so it eliminates the emissions of smoke. And also the efficiency rate of electric locomotive is much higher as compared to other types of locomotives for about 90%. Next. So here are some characteristics of electric locomotive. The first one is the lack of pollution. So as I said a while ago, the main power of electric locomotive is coming from the electricity, so it eliminates the emission of smoke. Electrification also results in higher performance, lower maintenance costs, and lower energy costs for electric locomotive. So electric locomotive is very ideal to commuter rail service with frequent stops. So it means that electric locomotive is highly used in high-speed lines such as Shinkansen in Japan, tsaka in TGV in France. So power for electric locomotives can come from clean and or renewable sources, including geothermal power, hydroelectric power, nuclear power, solar power, and wind turbines. Electric locomotives are also quiet compared to diesel locomotives since there is no engine and exhaust noise and less mechanical noise. On the other hand, the chief advantage of electrification is the cost for infrastructure. So the main disadvantage of electrification is the construction and the maintenance of overhead power lines or electrified third rail, the substations, and the control system. So to further discuss what is electric locomotive, here is Sibog to explain the alternating current.
Good evening. Sa introduction of alternating current naman, ano nga ba yung alternating current? Yung alternating current is an electrical current that reverses its direction many times a second at regular intervals. Mas preferred yung AC kaysa sa DC in long distances dahil na nami-minimize niya yung energy losses in which sa DC hindi siya ganon ka-effective. Next slide. Sino nga ba yung nag-invento ng alternating current? Pagka sinabing AC or DC, ang nasa site lagi na pangalan is si Thomas Edison or si Nikola Tesla. Pero base sa research ko, ang nakadiscover talaga ng alternating current is isang French instrument maker na nagngangalang Hippolyte Pixii na nabuo niya noong 1832. Gumawa siya ng isang instrument na nagko-convert ng mechanical energy to electrical energy gamit yung horseshoe magnet na nakakabit sa isang crank na malapit sa isang coil. Ginamit niya yung principle ni Michael Faraday, which is electromagnetic induction, na pagka may linapit ka daw na isang magnet sa isang coil or nagpaikot ka ng isang copper disc sa malapit sa magnet, is magge-generate daw to ng current. Pero ang trend kasi that time is DC na current. Pero ang nagawa niya is AC. Kaya na-deem niya to as useless. Kaya nagpakabit siya ng commutator sa design niya, which para maging dynamo na ang electric current na mailalagay is DC. Pero hindi siya masyadong hindi rin siya masyadong nagamit dahil masyado pang raw daw yung instrument na to. Next slide, please. In terms of railway naman, yung alternating current is ginagamit mostly sa AC traction and sa overhead electrification system. Dahil nga, sabi ko kanina na nakapag mas onti yung naloloss na energy pagka AC yung ginamit kaysa sa DC. Next slide, please. Single phase low frequency AC system. Dito naman sa single phase low frequency, noong December 1, 1909 sa United Kingdom, inadapt nila tong low phase single phase low frequency system. At nagsunod-sunod to noong May 1911, June 1912 at 1925. Pero in-announce noong 1926 na i-convert na lahat nung AC system na to bilang DC third rail. At ang last overhead electric service nga is noong September 1929. Pero inadapt naman din to ng 5 pang European countries, which is Germany, Austria, Switzerland, Norway, and Sweden. Next slide, please. Three-phase low-frequency AC system. Itong three-phase naman is nagkaroon ng unang practical AC locomotive na ginawa ni Charles Brown in Germany noong 1891. And isang Hungarian engineer naman ay gumawa rin siya ng isang AC locomotive sa Valentina, Italy noong 1899 at 1902. At dahil nakita nila na successful nga itong nagawa nilang AC locomotive, is inadapt sa North region ng Italy yung AC traction AC system na to. Tapos tinawag na itong Italian system. Itong image na ito, may kita nyo, ito yung unang AC locomotive nga na ginawa ni Kalman Kanto noong 1898 to 1902 sa Valentina, Italy. Yun lang. Thank you.
Next po is yung electric locomotive types. So meron po tayong 3 types sa electric locomotive. Yung direct current, alternating current, tsaka multi-system. Next slide po. Sa direct current po, yung flow ng electric current niya one direction lang, consistent po 'yun, tas paulit-ulit lang. Tas yung una pong naimbentong direct current na locomotive, ginawa po siya ni Robert Davidson noong 1837. Tas tinawag po tong Galvani. Yung naimbento po na locomotive na yon, ano siya? Ano, battery locomotive. So powered siya ng battery. Ang nagpapatakbo sa kanya is yung zinc acid batteries po. Pero hindi pa po siya nasasakyan ng passengers tsaka goods. Ang common voltage naman po na ginagamit sa direct current is 600 to 3,000. Pag third rail po, ang ginagamit nila is yung 600 to 750 lang po. And then pag OCS or yung overhead catenary wires, ang ginagamit po nila is 1.5 to 3K po. Bali dito po sa direct current, gaya po ng sabi ni Sir, galing po siya kay Thomas Edison. Dahil mahina lang po yung power na ginagamit sa DC, mas okay siya sa short distance lang. Tapos kailangan niya ng maraming substations para makapag-transmit ng sufficient na power. Tapos yung mga substations na yon, kailangan regular yung intervals nung nila, distance nila. Next slide po. Next po is yung alternating current. Ito naman po galing siya kay Tesla. Sa alternating po, yung flow niya is yung 0 to maximum, paulit-ulit lang. Ang unang alternating current naman na imbento na locomotive is gawa ni Charles Brown, yung inexplain ni JP kanina. Dito, dinemonstrate ni Brown yung long distance power transmission. Tapos yung common voltage naman po na ginagamit sa alternating is 15,000 to 25,000. Dahil malakas yung voltage sa AC, pang long distance siya, gaya nga ng sabi ni JP kanina. And dahil malakas yung power niya, konting substations lang yung kailangan. At sa alternating, ang laging ginagamit nila is overhead wires. Sa gastos naman po, sa AC, mas cheap yung mga equipments niya, pero mahal yung locomotives. Sa DC naman, mas mahal yung equipments niya, pero mura lang yung locomotives. Tapos yung pangatlo pong type, next po. Yung pangatlo pong type, yung multi-systems po, combine AC and DC. Sa multi-system naman po, meron na kasing mga locomotives ngayon na pwede nang gumamit ng dalawa. Yan nga, yung AC tsaka DC. So pwede siyang pang short distance, pwede rin siyang pang long distance. Parang mas tipid siya kasi pag yung mga station, short distance lang, pwede ka munang DC na low lang yung power na ginagamit. Pero pagka medyo malayo na, pang long distance, pwede siyang mag-shift ng AC. So, mas tipid siya. Hindi sayang yung power na ginagamit. Tas last po, next po. Yung battery locomotive. Bali, powered siya ng battery, ng mga onboard batteries. Yun nga, yung sabi ko kanina, yung gawa ni Robert Davidson, powered siya ng battery. Maganda rin to kasi pag nagka-problema sa sa mga power na pinagkukuhanan ng power, meron pang magagamit yung yung locomotive. May pagkukuhanan pa siya ng power. Makakatakbo pa siya. Sa battery locomotive, kunyari ginamit siya ng in case of emergency, pang reserva pwede siya. Pag hindi naman siya ginagamit, yung battery locomotive, nagcha-charge naman siya sa pantograph. Pero pag wala, pwede rin naman sa mga stations na ginawan nila ng charging stations yung mga locomotive na may battery. Yun lang po.
For the next topic naman, we have power transmission. What does power transmission mean? Basically, power refers to electricity, and transmission as a general term it means to pass on something from one place to another through a channel. In this topic, the channel refers to the high voltage power lines that carry electricity. Therefore, electric power transmission is the bulk movement of electrical energy from a generating side to an electrical substation through transmission networks. Alternating current is normally preferred as its voltage may be easily stepped up by a transformer in order to minimize resistive loss in the conductors used to transmit power over great distances. Electric power transmission, or simply power transmission, has three main components: the transmission towers, conductors or power lines, and the substations. Recalling the previous reports and discussions, basically, power plants generate electricity to be regulated by the electrical grid, which is the NGCP, and is distributed by electric distribution companies like the Meralco in Luzon. According to their website, Meralco is the largest private sector electric distribution utility company in the Philippines, covering 36 cities. They account for 55% of the country's electricity output. In 1903, Meralco was established as the Manila Electric Railroad and Light Company, providing service through to its name: 1, to provide electric light and power, and 2, to provide an electric street railway system to Manila and its suburbs. Dahil naman sa World War II, nasira yung railway system ng Pilipinas beyond rehabilitation. Kaya naman, Meralco gave up its transportation business. Instead, they focused on providing electricity. Now, Meralco just stands for Manila Electric Company. In 1980, Meralco, upon the request of government, started up and operated the country's first elevated light rail transit, the LRT, system in Manila between Baclaran and Caloocan. It was reminiscent of the pre-war role of Meralco in the city's streetcar system. Di ba nga before World War II, they have been a part of our country's railway. They have provided for electrification of Manila's railway system. At the end of the decade, Meralco turned over the efficiently functioning system to the government. One of the main components of power transmission are the conductors or the power lines. Yung mga utility companies kasi, they use two different types of power lines: transmission and distribution power lines. Kapartner ng mga power lines na to ay yung towers na kasama din sa main components ng power transmission. Transmission tower for transmission lines, and distribution poles or utility poles naman for distribution lines. Although limited lang sa power transmission yung topic ko, maganda magkaroon pa rin tayo ng knowledge about the two. Power is transmitted at high voltage and distributed at low voltage. According sa na-search ko, the core difference between the two is the transmission and distribution is that the distance wherein they transmit power. Mas malalayo kasi interval ng transmission towers compared to distribution poles na halos bawat kanto meron. Ayan. So how is power transmitted to the electric locomotives? From the power grid, power is delivered to transmission networks. And according nga sa previous reports last week, wala daw tayong traction power network sa Pilipinas. So from the transmission networks, power is supplied to the substations. From there, electric locomotive draws its power either of the collection methods na ma-mention ko sa mga next slides. I won't be explaining them in detail kasi may mga group na naka-assign na mag-report sa kanila. Yan. First collection method is the trolley pole. A long flexible pole which engages the line with a wheel or shoe, used to transfer electricity from a live electrified overhead wire to the control and electric traction motors of a tram or trolley bus. Para mas madali nyo maalala, the trolley pole pretty much resembles a long fishing rod. The second picture is a close-up view of the trolley wheel na nakakabit sa dulo ng trolley pole. It also has its disadvantages. If the troller cart derailed from the overhead wires, it will fall with a loud crash onto the roof of a tram car and it's difficult to reposition the wires. These drawbacks prompted a search for better ways to connect to the power wire. Next naman sa trolley pole is the bow collector, a frame that holds a long collecting rod against the wire. Like the trolley pole, bow collectors are also used in tramways. Short discussion lang ng difference between tram and trains. Trams are short-distance transport system with only 1 to 2 coaches, while trains are heavyweight long-distance transport systems that have more coaches to increase its passenger capacity. Bow collector consists of a metal strip which are placed on the top of the vehicle. Springs are used for getting an upward pressure so the bow will have continuous contact with the overhead wire. The third collection method naman is the pantograph, a hinge frame that holds the collecting shoe against the wire in a fixed geometry. These three collection methods, the trolley pole, bow collector, and pantograph, all make use of the overhead line. Ang pinagkakaiba lang nilang tatlo are the components that touch the contact wire to collect power and transmit it to the electric locomotive. Now, we know that overhead catenary system is not limited and not exclusive for the pantograph only. Share ko lang din kasi may napanood akong video na both the bow collector and the pantograph can be used simultaneously sa iisang overhead wire lang. Ayun. Aside the previous collection methods naman, we also have the third rail. An additional rail supplying electric current. Again, hindi ko na sila i-explain masyado in detail kasi may group na naka-assign para i-report sila. The third rail is usually located outside the two running rails tulad nung nasa unang picture. But on some systems, it is mounted between the two rails, like in the second picture. Electricity is transmitted to the train by means of a sliding shoe, which is held in contact with the rail. For the next reporter naman, since may sakit yung kagrupo namin, I will be playing a pre-recorded video of his discussion about the topic.
Next topic ay yung driving the wheels. May two main ways para ma-transfer yung electric power sa train, yung overhead lines at yung third rail. Ito yung diagram kung paano nagana yung train gamit yung overhead lines. Overhead wires. Yung wires na ito ay yung catenary at yung contact wire. Yung catenary ay yung sumusuport sa contact wire para maging stable. Yung contact wire naman, yung mismong wire na nagdadala ng electric current na dinidigitan ng pantograph. Yung pantograph ay yung kumukolekta sa electric current mula sa contact wire. At yung current na ito ay dadaan muna sa surge arrestor at circuit breaker. Ano nga ba yung surge arrestor? Ito ay isang safety device na nagpo-protect sa isang electrical equipment sa overvoltage. Next na step naman ng electric current ay yung transformer. Tapos pupunta naman sa rectifier para ma-convert yung AC papuntang DC. Tapos yung converted na DC, pupunta naman siya sa auxiliary inverter para ma-convert ito sa three-phase AC. So bakit nga ba kino-convert yung AC to DC tapos binalik uli sa DC, sa AC? Base sa nabasa ko, ginagawa ito para makapag-produce ng maximum effective torque para sa traction motors. Yung traction motors ay yung nagpapatakbo ng gulong ng train. Tapos meron ding naka-install na mga cooling fan dahil nga nagpo-produce ng sobrang init yung mga machine na ito. Ito naman yung isa pang way para makakuha ng electric power yung train, yung third rail. Dagdag na relays na may electric current, kaya tinatawag din siyang conductor rail. Yung device naman na naka-connect dito ay yung contact shoe. Ito yung nagko-collect ng electric current galing sa conductor rail. May dalawang position kung paano sila naka-install. Yung una, yung side running at bottom running. Yung pinagkaiba lang naman nila, yung kung paano sila nakanikip. Pero may kaunting advantage yung bottom running since nasa ilalim siya. Mas safe ito ng konti sa side running at hindi rin ito masyadong apektado ng snow at ice. So ano nga ba yung mas maganda? Third rail o yung overhead? Sinama ko na rin dito sa report ko yung mga advantage at disadvantages ng bawat isa para hindi na magtatanong mamaya. Sa third rail, advantages nito ay mas mura siya, less maintenance, good for short runs at suitable siya para sa mga subways. Disadvantages yung high risk ng electrocution dahil nga naka-expose yung live rail sa lupa. Tapos madalas din siyang maapektuhan ng mga flood, ice, tsaka snow. Hindi rin siya suitable para sa mabibilis na train. Tapos poor power transmission over long distances. Yung sa overhead lines naman, yung advantages nito ay high power transmission, long distance transmission, at low risk of electrocution. Tapos suitable din siya para sa mga high speed trains. Tapos disadvantages yung dahil niya pangmalayon siya, mas mahal yung pagbibuild nito. Tapos mas complex din sa third rail at yung vertical clearance ay kailangan ma-secure para ma-install yung maayos to. Ayun lang po.
Next topic po, nandito po ba si Glenn?
Hello. So for wheel arrangement po, meron tayong dito dalawang pag-uusapan. Una is yung white notation system and then yung UIC classification system. First is yung the white notation system. The white notation system for classifying steam locomotive is not adequate for describing the varieties of electric locomotive arrangement. Sabi dito, hindi daw sapat yung white notation system para i-describe yung wheel arrangement ng electric locomotive. But first, ano ba yung white notation system? Yung white notation, it is a wheel arrangement classification developed by Frederick White in mid-1800s. Kina-classify ng notation na ito yung iba't ibang forms ng steam locomotives and kung ano yung pinagkaiba nila sa isa't isa. Bali yung notation na to, by counting the wheel siya, unlike sa UIC na by axles yung pagbilang, that is why puro even numbers yung notation. Bali, pag-uusapan natin further later yung about sa UIC. Tapos, dito sa white notation system, separated by hyphen. And yung first number is for leading wheels. Yung second or yung middle number is for driving wheels, which is ito yung nagpapagalaw sa locomotive. And then yung last number is for trailing wheels. Next. So for example, the wheel arrangement of this one is 484. Meaning yung 4 meron siyang 4 na leading wheels, tapos meron siyang 8 na driving wheel, and meron siyang 4 na trailing wheels. Next po. So for UIC classification system naman, sabi dito, it was typically used for electric locomotive. It could handle the complex arrangement of powered and unpowered axles, and it could distinguish between coupled and uncoupled drive systems. Sabi ko nga kanina, yung white notation is for steam locomotives. Now, ano naman yung pang electric locomotive, since ayun naman kasi talaga yung cover ng topic namin. So for electric locomotive is yung UIC classification system. Na-develop yung system na to by the International Union of Railways. And UIC stand for Union International de Chemins de Fer. So galing siya sa French term. Pag sinabing UIC classification system, by axle yung pagbilang ng wheel arrangement. And it has a lot of more rules than the white notation. Next po. So UIC uses the following structure. Uppercase letter, which designates consecutive powered axle. For example, yung A na malaking letter, ibig sabihin nun, meron siyang 1 powered axle. Yung B naman, na malaking letter din, meron siyang 2 powered axle. And yung C, meron siyang 3 powered axle, and so on and so forth. Yung lowercase o naman, designates for driving wheels. For example, pag sinabing bow, which is yung may malaking B, tas may maliit na O, meaning 2 powered axle driving wheel siya. Next is yung numbers, which is designate to consecutive non-powered axle. For example, 1. Ibig sabihin for single axle siya. Next is yung prime symbol. Axle indicated by a single letter or number are mounted on a bogie. And then parentheses, group letters and numbers describing the same bogie. And yung plus sign, which is shows completely separate mechanical system like sa mga multiple units. Next po. So, for example, yung ito, yung una yung BB. Ibig sabihin, meron siyang 2 powered axle na mounted on an individual bogie. Tapos next is yung Bobo, which is 4 powered axle na may dalawang designated driving wheels, while each 2 powered axle are mounted on a bogie. And most common wheel arrangement in modern locomotives tong Bobo. Next is yung Coho, which is 6 powered axle siya na may dalawang designated driving wheels, while each 3 powered axle are mounted on a bogie. And next is yung etong Dodo. 8 powered axle siya na may dalawang designated driving wheels, while each 4 powered axle are still mounted on a bogie. And next is itong A1A. A1A. Meron siyang dalawang truck na may unpowered axle sa gitna. Kasi 'di ba yung number, it denotes for unpowered axles. Next is yung Bobo plus Bobo. As in permanently coupled carriages in a train set. Separate na yung mechanical system. Bali, 4 powered axle na may dalawang designated driving wheels, while each 2 powered axle are mounted on a bogie pero may dalawang separate mechanical system. Next is yung Boko, which is meron siyang 2 axles at the front and 3 in the rear. And then yung Kobo, 3 axles at the front truck while 2 in the rear. Yun lang po. Thank you.
Pa-type na lang po yung questions niyo sa chat box.